Good afternoon, grade 10. Our lesson for today is about alkenes and cracking. This is teacher Mildred, and this is chemistry, grade 10. From our previous lesson, we discussed about alkanes. We know that alkanes are hydrocarbons with a single bond. Therefore, they are saturated hydrocarbon. The ability of carbon atoms to form double bonds gives rise to the alkenes. The alkenes are another family of hydrocarbons or homologous series. Alkenes are unsaturated hydrocarbons, meaning molecules of these compounds contain a C double bond C. The general formula for alkenes is CnH2n, where N stands for the number of carbon atoms. And the names of alkenes end in "-ine". Such molecules of alkenes are unsaturated because it is possible to break this double bond and add extra atoms to the molecule. The simplest alkene must contain two carbon atoms. Therefore, the simplest alkene is called ethene. The table shows the number of carbon atoms, the general formula of the compound, the condensed formula of the alkene, and its name. If there are two carbon atoms present, therefore the general formula which follows CnH2n would be C2H4. Writing the condensed formula, it would be CH2CH2, and the name ends with "-ine". Therefore, the name of the compound is ethene. If there are three carbon atoms, therefore the general formula would be C3H6. Condensed formula would be CH2CHCH3, and the name would be propene. If you have four carbon atoms present, then the general formula would be C4H8. Writing the condensed formula, it would be CH2, CH, CH2, and CH3. The name of the alkene is butene. If there are five carbon atoms, the general formula of the alkene would be C5H10 with a condensed formula of CH2, CH, CH2, CH2, CH3, and the name of the alkene is pentene. If there are six carbon atoms, so therefore the general formula would be C6H12 with a condensed formula of CH2, CH, CH2, 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 CH3, and the name of the alkene is hexene. The same principle follows for heptene, octene, nonene, and desene. The picture shows the structural formula of some alkenes. Let us start with the simplest alkene, which is ethene, with the formula of C2H4. Therefore, the first carbon atom would have two hydrogens bonded on it, and the second carbon atoms would have two hydrogens bonded on it as well. So therefore, the condensed formula would be CH2CH2. If you have propene and the first double bond is on the first carbon atom, so therefore the formula would be CH3, CH, and CH2. If you have butene and again the double bond is on the first carbon atom, the condensed formula would be CH2, CH, CH2, CH3. And if the double bond is on the second carbon atom, you need to indicate the position of the double bond. The condensed formula would be written as CH3, CH, CH, and CH3, but the name would change. You need to indicate the position of the double bond. Therefore, the name of the alkene would be but-2-ene. 2 indicating that the position of the double bond is at carbon number 2. If the position of the double bond is at carbon number 1, you can just write it as butene or but-1-ene. The photo shows another example for some alkenes, their structural formula and their condensed formula. If you have pentene and the double bond is at carbon number 1, the name of the alkene would be pent-1-ene or simply pentene. Writing the condensed formula, it would be CH2, CH, CH2, CH2, and CH3. But what if the double bond is at carbon number 3? Again, you need to indicate the position of the double bond. So the name of the alkene would be pent-3-ene. The presence of the C double bond C in an alkene molecule makes alkenes much more reactive than alkanes. Remember that alkanes only contain a single bond. Other atoms can add on to the alkene molecules when the double bond breaks open. This difference produces a simple test for unsaturation. It is the presence of the C double bond C in an alkene molecule that gives the homologous series its characteristic properties. For this reason, the C double bond C is known as the functional group of the alkenes. How are we going to distinguish if the substance is an alkane or a saturated hydrocarbon or an alkene which is an unsaturated hydrocarbon? The first test is the bromine water test. If the compound is an alkene, the bromine water, which is brown in color, will turn into colorless, or it will decolorize the bromine water. With an alkane, there will be no reaction or no change. Another test is the acidified potassium manganate. If the compound is an alkene, the purple potassium manganate will turn colorless. And again, with an alkane, there will be no reaction or no change. How do we obtain alkenes? Alkenes are made by cracking alkanes. Large alkane molecules obtained by the fractional distillation of petroleum are passed over the heated catalyst. The catalysts for cracking are silicon 4 oxide and aluminum oxide. Let us now discuss the cracking of alkanes to obtain alkene. There are two possible ways. The first one is by cracking higher alkane to produce a simpler alkane plus an alkene. For example, if you have C10H22, which is decane, cracking decane would give you a simpler alkane, which is C8H18 or your octane, plus an alkene, which is C2H4 or your ethene. Subtract 8 plus 10 and you would be having 2, and subtracting 18 from 22 would give you 4. Another possible products are heptane and propene. If I will use C7H16, which is your heptane, subtracting 7 from 10 would give you 3, and subtracting 16 from 22 would give you 6. Therefore, the alkene is propene. Another possible products would be pentane and pentene. Subtracting 5 from 10 would give you C5, and subtracting 12 from 22 will give you 10, which is your pentene. Let us have another example. What if the higher alkane is octane, C8H18? There are many possible answers. If I choose 4, which is lower than octane, I would produce butane with a formula of C4H10. Subtracting 4 from 8 would give me C4, and subtracting 10 from 18 would give me H8. Therefore, the name of the alkene is butene. Another possible products would be butane and pentene. If I would choose to use C3, which is lower than octane, subtracting 3 from 8 would give me C5, and subtracting 8 from 18 would give me H10. Therefore, the alkene that I will form is C5H10, or your pentene. Another possible reaction would be cracking a higher alkane to produce an alkene plus another alkene plus hydrogen gas. For example, if my alkane is decane, which is C10H22, I will choose two possible alkenes. Let's say I choose C7. Subtracting 7 from 10 would give me C3, and subtracting 14 from 22 would give me H6 plus hydrogen gas. Therefore, the products are heptene, propene, and hydrogen gas. Another possible reaction would be if I have C9H20, which is your nonane. Cracking nonane would give me, for example, I choose C4 and H8. Subtracting 4 from 9 would give me C5, and subtracting 8 from 20 would give me H10. Therefore, the products are butene, pentene, and hydrogen gas. There are three major uses of cracking. First, cracking is used to make alkenes. Second, cracking is also used to make hydrogen gas. And third, cracking is used to make petrol from the higher fractions, since there is a greater demand for petrol than for kerosene. This is done by fractional distillation in a fractionating column. And that's the end of the lesson about alkenes and the process of cracking. For your practice exercise, show the cracking reaction for the following alkanes: heptane, octane, hexane, pentane, and nonane. Take note that there are many possible products, and you can choose if your reaction would be cracking a higher alkane to produce a simpler alkane plus an alkene, or cracking a higher alkane to produce an alkene, another alkene, and hydrogen gas.